All right, so I'm gonna do some more chess streaming or chess programming. Let's try to get this reinforcement learning engine to, well, fake reinforcement learning engine to actually do something. Last time I left off, it wasn't really working. So I built this engine that produces a feature representation for the board position, and then runs a linear model, linear weighting of those features, and produces a score. And then I had a sample from the score, or a sample from the distribution of valid moves, and choose a move randomly with a higher probability for higher scoring moves, or for moves that led to higher scoring positions. And what we did last time was we have this main script that tries to do some learning, and it plays a bunch of games, and then it just sort of scores every single position, or rather, every position is marked as either a winning position or a losing position based on whether you win or lose. And then it makes an update, so it tries to classify the winning positions from the losing positions, and it really just didn't seem like it was working. So we can do a few tests to try to figure out whether there's a bug, or whether the math might not actually work out. Like I did in my head, I set it up as a classification problem, but maybe classification is not going to work. My thinking is that it should fake reinforcement learning, because the real power of reinforcement learning is that you get a reward signal at the end of the game, and the reinforcement learning is all about figuring out like what led to that reward. What are those positions that led to the winning or losing, and we can kind of fake that with this, because the positions that we're going to see in the middle game that lead to either wins or losses will kind of cancel out, right? When it's a win, you'll think it's a winning position. When it's a loss, you'll think it's a losing position. But the positions where near the end game, or even near a checkmate, those will almost always lead to checkmate, and that'll those will be more certain to be positive or negative, or winning or losing positions. But we'll see. I don't know if that actually works out, and if it doesn't, then we'll just have to use real reinforcement learning, which is where I want to head eventually. So for now, the first thing I want to test is I want to write a couple of tests to make sure that that the scoring system is working correctly, or that the feature representation is working correctly. So one learning features. One aspect one invariant I want to maintain is that flipping the whose turn it is should just negate the features. It should just negate the features, and that works for the type of features I was using. Like I was using material count, and so if I correctly implemented it, then if you're up 4 pawns, and then it's the other person. If you flip it to the other person's turn, then it should be that you're down 4 pawns, or that other person, the opponent, is down 4 pawns. So it should be symmetrical. But let's see. So we're gonna give it we're gonna create a test function, and let me pick a board position. It really doesn't matter. I had this position I created from. This position I pulled from a game that the other bot, our Minimax bot, was playing, and it was, it was a position where the Minimax bot, for some reason, played a really terrible move. It played here, and I didn't understand it. I didn't understand why the code would have thought that was a good move. But anyway. And this is a totally different bot now, so it doesn't really matter. It's probably not going to make the same mistake. I mean, I would think. I mean, let's see. Stockfish just says probably take something with a pawn. Oh no. Okay, Stockfish says to develop. No, to move the bishop out of here. I guess the bishop's blocking this pawn, so maybe it's worth moving. I don't know. But anyway, this is a position early on in the opening. It's not a good opening, but it's one where a lot of pieces are on the board, so it's good to test our piece counting code with it. So I'm going to use that position. I'm also just going to create a different one So I'm going to say, I'm just going to set this to be black's turn by changing the fen. And I think that should be correct. I don't know, these numbers won't be possible. I think these are the number of, well, it doesn't really matter if it's a possible position. I mean, if I plug this in, as long as Lichess doesn't say this is a problematic fen, then yeah, so it's just black's turn with the same position. I guess you can maybe have something like this happen with by moving the, oh no, you can't move the king because you lose castling rights. You can move the queen back and forth or something, and the knights back and forth, and create this position. Okay, so let's see. So this is board. So the first board we're going to say is the score is going to be, oh, so let's create an engine. Let's create a learning engine from our from learning. I realized stylistically I'd named learning engine in caps or in camel case, which is, I have to look up if that's the right Python style. I know Python files like to be lowercase with the we call it snake case, I think, with the underscores, but the names of classes should be in camel case, and so I have to figure out the correct style there, but it's not a big deal. Okay, so let's see. Let's create a new learning engine, and I think I had to give it some stuff. What do I give it? So I give it like, I actually don't remember what I'm supposed to be giving it, but I passed in none before. All right, so we created a learning engine, and we just want to score the position. So score is equal to engine.score. No, sorry, I don't want to score it. I want to get the features. Okay, and then I want to do get the other direction. Oh, I didn't do this. Opening error flipped. Okay, and we're gonna say flip features is engine dot features board. No, flip board. And then we're gonna say, let's just print these out first. So features for white to move, and it's in the features come back as a numpy vector, so I don't know if I can just print. Let's just do it this way, and just do black to move, and we'll just print flip features, and lastly we'll do an assertion. Let's do it this way. So I'm using NumPy's all close method just in case there's some weird floating point errors, which there shouldn't be for such a simple feature vector, but I don't have NumPy. I have to import NumPy. But let's see, so we want features, flipped features. All right, let's run this test and see what happens. All right, it says it failed. Except those look like that looks like it's correct. Oh, well, I don't actually. We should do the count ourselves. I think this is saying that white was down a pawn. I think. We're always scoring the position for the player who just moved, and the reason for that is we want to always consider the next positions after we make a move. So like the resulting position after a move, we want to score it. So in other words, if it's white to move, then we want to score the next positions that are possible, and all those will be black to move. So this is showing right now. I think it was white to move, so black had just made a move. So black was down a pawn apparently. We'll check the board in a second, and then all the other pieces are even. There's no checkmate. This last one is checkmate. Now why did it fail? because it should have. It said false is not true. So it said that. Oh, I was just going to negate this. Okay. All right. So it passes the test, which is good, I suppose. But this is maybe this position is not a good one for us to be using because, it's materially equal except for pawn. No, let's see. Is it correct? So, black has 7 pawns. White has. Wait, hold on. Oh, well, yeah, white has 8. Yeah, so that's. How did this game happen? How did this happen in the beginning? I think it must have been a. Yeah, I think our bot didn't take back. I don't remember how this happened in the game, but anyway, yeah. So it's correct, but let's do a little bit more interesting of a position. One thing we can do is like grab. I was gonna look at the current featured game and just grab the current position, but this is a pretty that end game is gonna not a good test for material count. I mean, I'm pretty confident in the material count now. I mean, it should have been 0. So how about let's just make a random one. Let's look at a game that the bot recently played for fun. I guess we want to go to profile. I guess we had a random challenge here, and our bot timed out because I don't know what settings I had it on. But okay, so in this position, it's even. All right, every piece is on the board. Am I missing anything? No, the queens. No, queens are on the board. Yeah. Okay, this is not an interesting position. I mean, it is interesting. Oh, I don't know if it's interesting, but it doesn't show any material difference. All right, I'm just going to create a position. Let's just make it so that there's an imbalance in every possible way. So I'll go to board editor, and it doesn't actually matter where the pieces are. So I'm just going to start deleting pieces. So we get rid of a pawn for white, a bishop for black. Let's say black is missing a queen and a knight, and white's missing both rooks. That should be fine. All right, so I'll copy that, and I'll just make this. I'll call it imbalance material. And whose turn is it? This is white to move. So white, and then we'll just make another one that's just black. All right, so now we'll change the test. All right, okay, so, and after this, I think I'm going to be pretty confident. Now, I'm going to assume this is going to be correct. Actually, what we should do is look at the board and decide what the score should be, or what we expect the vector to be. This is black, okay. All right, so let me see. So what did I do? So I got rid of the rook, so we should see, okay, this is white to move, but that means that we're going to score it from black's position. It's a little confusing, but so we should see +1 for the first entry, and then -1 for the knight entry, -1 for the bishops, and +2 for rook, and -1 for queen, 0 for king because there's one king for each side, and then checkmate should be 0. So I already forgot what I said, but let's see what we get. All right, it failed, which is weird. That means there's a bug. Did I do something wrong? No, I must have done something wrong because these are the same. So I didn't actually flip it somehow. Did I not? White, black. That's weird. White. Yeah, I just didn't use the black position. Okay. All right, so yeah, so it passes, but now let's look at the vector to see if it's what we expect. So we had for features for white to move, that means that we're scoring it from black's perspective. We're up a pawn, black is up a pawn, down a knight, down a bishop, up 2 rooks, down a queen. Yeah, that's correct. Okay, that means this is sort of working. So what else could be going wrong? So, yeah, last time I had set up this game where, I mean, it's not really a game, but the setting is that you keep playing games, and whoever wins, or if white wins, you know what? One of the things I want to do is I'm going to turn off the claim draw. I'm going to get rid of threefold repetition as a way of it being a draw. And I'm just going to say that a game can't go past 100 moves. So to do that, I think we do that. Where's the, is this the, this is the, okay. Board dot moves, full moves number, whoops, full move number is less than, whoops, max moves. So we'll just call it a draw if it goes to 100 moves. Okay, and I think I'm going to say if outcome and outcome, I think this will protect against the game having not been ended, and then if it's not ended, it'll count as a draw. Okay, let's just run it again. We'll just talk about what's happening with this. So we're playing a bunch of games, and we're learning, or we're supposed to be learning. So the learning algorithm is updating the scores. These are the parameters, the weights for white. And I've hard coded the pawn value to be 1. So these are the different values for the other pieces, and this is mate. And it's I realized as I was looking at this after the last stream, since the black engine is the same thing, it's not getting any updates. For the most part, as long as you have like positive values in these, like each of these is good, right? Having more pawns is good, having more knights is good, having more bishops, more queens, more kings, I guess doesn't matter, but and having mate is good, or giving checkmate is good. Any positive values here will be good, so it's kind of unfair. So one thing I think I might want to do is I can just hard code the black player to be our standard material values that we're used to, and see what happens. See if we can learn essentially a better set of material values, or at least match it. And yeah, so we're winning more than we're losing, but we're drawing a lot, which is not great. But that's to be expected. I think one of the other missing things here is that we're not going to see, if you have a bot that's just playing randomly, trying to improve material imbalance, it just gets to positions where, it can get to positions where you can just shuffle your pieces around and you're not going to make any progress. But at the same time, you're playing against another bot that's playing randomly. I'm sure you're going to be able to catch some hanging pieces, and but then, like, let's say you're stuck with it. Let's say you're up a queen in the end game. Will this bot find checkmate? Probably not. Probably not. It would have to be really lucky, right? When you think about, just for example, like the king queen checkmate patterns, if you're not doing it on purpose, you're just shuffling around, you can probably imagine it not happen, without looking ahead. It's easy to imagine that you wouldn't be able to find the checkmate. Anyway, so let's set the black player up to be to be sort of pretty good at the beginning. So we're going to set the weights. I'm going to set it to be, all right, 1, 3, 3, 5, 9, 0 for king, and then mate, let's give it 10. Let's give it more than 10. Let's give it 30. Okay. So now I would expect we're going to lose a lot now, right? So yeah, this is good. So we're starting out and we're losing a lot. The question is, will we ever win? We might never win because our initial weights are bad. So okay, good news that The fact that we're losing a lot means that there is opportunity for a good set of weights to outplay a random player. Problem is that we're not making progress. Oh, we had a win. So now from that win, do we now know something about? I don't know. Let me think. Yeah, this could be just the flaw. So it might just come down to the fact that my fake reinforcement learning system is just is not accurate. Right? It's like incorrect. Because think about these moves. The only position that we should be really confident about scoring is like forced mate positions, and that's just one position out of many in any game that ends up being a win. So, especially in the situation where we only have one win among so many other games. Interesting. Now the weights are all zeros. I think we have to think carefully about what we do when we have a loss. Okay, so when we have a loss, I'm classifying every position in that loss as a losing position. And that's... that might be correct. But then the downside is... Yeah, I guess we're not seeing enough wins. Okay, you know what we need to do? We need to take advantage of the fact that we actually get to see black play well. Like when this happens, we see black play well. And so we should learn that the positions that black was getting are actually good. So one thing that I'm missing here, right? So here I have like a little loop here that says learn from white positions. But what we're not doing is we're not learning from the opponent's positions. So let's try to do that. So when it's a win, so I have draw as a separate loop or a separate condition. That's fine. All right, so let's try this. So I'm gonna learn from black's positions, and let's do black positions, and we're updating our weights to be. Yeah, that's interesting. I think what I'm doing here is closer in spirit. Again, this is all fake reinforcement learning. I'm not properly handling the fact that there's transition probabilities between different parts of the game, but I'm faking it. But this is kind of like a passive reinforcement learning where I see like two agents play a game, and then we're just trying to figure out, okay, well, how good is each position? How much reward does each position lead to? So let's do, I think I just want to subtract this. So like these are now, let's see, losing positions, and these are now winning positions. Yeah, we're going to pretend they're winning. We're going to pretend they're losing. Again, I'm putting quotes around them because these are not like the bots are basically playing randomly. So okay, so even though it led to a win, it doesn't really mean it's a winning position. So now when black wins, which is what we've seen most of the time, we did not have. This is correct. Yeah. When black wins, all the white positions were losing, so we were winning. We kept training about losing positions. So we were like, all our training data was telling us here's what positions look like losing, but it wasn't telling us what positions look like you're winning. And so this is going to give us that to balance things out. And okay, just in that case, we want to make the scores for those positions higher, so we're adding the value to the weights. That's like a homework problem. Is like if the perceptron learning update, you can think of it. It's technically like a gradient update, like many neural networks are, but there's a homework problem that I usually give every time I teach AI, which is just prove that the score goes increases when you add the features for the positive examples in the training set. Okay, so this also is I guess the drawn positions. I want to think a little bit more carefully about what to do about draws. Maybe we should like do nothing when we get a draw. I don't know. I mean, we want to train the bot to avoid draws, so I guess I'm just treating them as losing. So these are not really drawn positions, and these are. Oh shoot! But then in both cases we want to subtract. That's kind of weird. All right, so that's fine. Let's try that. Let's see what happens. So again, we're playing as white, and we're monitoring how many wins we have. Black is initialized with its really good, not really good, but like the standard weights that we're not weights, the material values that we're taught when we learn chess initially, and yeah, what we're seeing is still for some reason the weights keep going to 0. All right, so one other test I want to do just before I there could be a typo, but I just want to see, like, out of curiosity, if I initialize white to the same value, will it move away from there? Like if I set the white engine to also have these values. Oh, it doesn't like that these are integers, so I'll make them floating points. Yeah, so now it's a lot more even. We're getting, well, that's kind of interesting. I don't know if we can, this is just probably just random fluctuations, but one of the things I'm always wondering is, will it value bishops more than knights? But yeah, it's probably just random. So I think because of draws, it's shrinking these quite a bit. Not a bit, but like it's sort of consistently shrinking these values. Weird that the mate went from 30 to 25.00. Right? It's like, why was that such a round number? So I don't know if this is telling us anything, but getting some spam in the chat. All right. Let me open Twitch moderating. All right, let's see. So is anything changing? It's still about the same, but it's never like growing. It's kind of interesting. Okay. So there's a couple of possibilities, right? This could mean that it's like functioning. Let's try running it from a random set of weights, or let's give it some bad weights. Let's just say it's worth 1. Everything's worth 1. So it's going to be better than random, I guess. Yeah, it's kind of cheating, but like, why not? Let's just say mate is worth 30, so it'll always go for mate whenever it's available. But yeah, see, it's like shrinking these values, which it really shouldn't, because we want the knights to be worth more than more than pawns. I mean, we want the queens to be worth more than pawns. I mean, you might be able to argue, right? There might be an argument to be made that like there are some positions where a pawn is worth more. I mean, we know about those, but not more than a queen. I mean, the reason the pawn is worth so much oftentimes is that it can become a queen. Okay. Let's see. Yeah, it looks like the numbers are just shrinking. So I think it has, maybe that has to do with the draw situation. Okay. I don't know if I needed to. Okay, anyway. Yeah, so. Oh, wow. Okay, so now they went to 0. So the something is just making these numbers shrink. That's not what we want. So when we're winning, so when we win, we learn from these positions, we increase the score for all the positions that we saw. When we lose, we decrease the, sorry, when we knew that black lost, and so we look at all the positions black saw, and we just want to make sure we, yeah, so every time we use the features function, we're getting the score for the player to move, so that should be okay. Not the player to move, the player that just moved. All right, so learning position. The other thing I'm thinking about is, I mean, did this go the right direction when we said we were up a pawn? Like if it was white to move, it was, you know, up a pawn. So let me just see what the imbalanced material do I still have open. Yeah, so it's white to move, which means that's where it means black is considering reach, you know, the quality of how good it is to reach this position. So it's really, it's the score from black's perspective, and black is up a pawn, so it's +1. So yeah, positive score makes sense. I just wanted to make sure we didn't want a negative score, because I don't allow the scores to go negative. I could also be like really hindering it by forcing the pawn value to be 1. It's possible I should leave that as free. I can make that free. Oops, I'm in test. Now let me turn that off. I'll set that to be, where is that? That is happening here. So let's do that. Oh, I see. I was clipping this to 25. That's why it was. Oh, okay. That's what happened. So I never allow the weights to be greater than 25. That was because if the weights get too big, you get numerical problems. So let's just set this to be the maximum value. And all right, let's run it again. This time I won't. This time I'm not clipping it. Sorry, I'm not forcing the pawns to be worth 1. They're just initialized to be worth 1. Oops. So the pawn went up a little bit, but yeah, it's weird that when that pawn's down, everything is just shrinking kind of equally. And we have a lot of losses, but that should be fine, because we should learn from, you know, what made black win. So you would think that it would try to match what black's doing. But maybe my thinking is just, yeah, this could just be a flaw in my fake algorithm, which means we have to really get into the real thing, and then I have to decide which algorithm to use, which I don't want to do right now. All right, so this is still shrinking to 0. Oh, so now pawn's worth very little. This might not be so bad, but no, it's bad. It's not winning. It's not increasing its win rate. So Um, let's just run through the logic to make sure it's doing what I intended to do. All right, so this is if white wins. When white wins, we should be thinking of every position in the game as winning for white or losing for black, and our weights are intended to be classifiers for winning or losing positions. So it should score higher if it thinks the player it should score higher if it thinks the position being considered is, oh, you know what? Do I have this backwards? Okay, let's see. So I'm storing the position here. This is the position before white made a move. Yeah, this is before white made a move. So I think I have this backwards because I think these are the positions that come after black made a move. Oh, you know what? This is tricky. So we have to think about, what do we want here? So the thing that's tricky about this is that my scoring function is is to score the resulting position after making a move, but this is the resulting position. I mean, this is before making the move, so this is the wrong side. I kind of think this just should be black positions. Oh, sorry. Engine white features board. This should be black positions. And just to like make it clear, this can happen before the move reasoning happens, because this is not about the move reasoning. This is just about what position did black reach after making a move, and then this is what position white reached after making a move. I don't like that space. Okay, so let's try it again and see if that does anything different. It's probably going to do the same. Well, now it's increasing. I guess that's better. I don't know. Pawns are worth still more than they should be. Yeah, let's see if I made a change before I finished going through the whole thing. So is this correct? So now I'm storing these positions to remember what are all the positions that black ended up deciding to go to. Right, those are the positions that black decided to go to because they were higher scoring positions when black made a decision. And then these are the positions that white decided to go to. And now when we learn that, okay, in this game white won, which means that all the positions that white considered, we want to encourage those more. So these are all the positions that white had scored previously, but now we want to score them even higher. We want to score them even higher, and we do that by adding the position value to the weights. Okay, that makes sense. And then these are the positions that black saw. I'm sort of sneakily looking at these numbers while I'm trying to reason through this. Like, these numbers look, I mean, I don't like the queen being smaller than the pawn, but the rook's higher, so I'm trying to, like, maybe I'm hallucinating like a good result. I like that the rook is worth more, but it might not actually be doing anything. All right, let's see. So now for the black positions. The black positions, these are the positions that the black engine chose because you know what, I don't think I can do this. I want to score from black's positions, but I can't assume. Well, I guess it doesn't matter whether the current weights were used to select it or not. All it matters is that these positions we know they're bad, so we want them to be scored lower. Well, yeah, you know what? It goes against the perceptron. Oh, maybe all of this goes against the perceptron. Maybe to make this correct, I have to actually use the maximum scoring position as the move. Because if I'm sampling from a distribution, I don't know that it was the maximum scoring position. Then it's not properly the perceptron loss. That could be the problem. Yeah, these numbers are looking pretty good. I mean, they're not, they're not great, but if we scroll back and just look at, like, here's what the I should be putting this in like a plot or something, but this is so early on in the game we had 100 losses and 80 draws and 11 wins. So let's say look at the wins to losses ratio. So it was 10 to 1, right? Or 1 to 10. Do we have something better now? Maybe. I mean, it is better, but is it actually better, or is it just an illusion? I mean, and these scores look, I mean, these weights look better. Mainly just comparing the pawn to the, minor and major pieces, except for the queen. I don't know why the queen is not worth much. This might be sort of working. But yeah, I mean, this stuff here, this algorithm is totally wrong, right? So it's not totally wrong. It's going to push things kind of in the right direction, but it's like unnecessarily reducing scores and increasing scores that might be already good, and so then it's going to, I mean, I had to think about the math about whether it's actually valid what it's doing. All right, so far it looks like it's just scoring like non-pawns as worth 2-ish, and pawns are worth 1.6. I'm gonna start over, even though this is gonna take a while to get back. I just want to print some more stats, because like trying to do in our heads the win ratio is not it's not great. Okay, so let's see. So I'm gonna do here, wins, losses, draws, and I'm gonna do let's do win rate. There's a missing colon here. Win rate, and let's do wins, losses, draws. Yeah, I think there was a problem here before where there will be a divide by 0, but there won't be a divide by 0 if I do win. Okay, yeah. So win rates will be wins divided by wins plus losses plus draws, and wins over losses are just wins over losses. So we'll get a ratio. Divide by 0, because losses is 0. Ah, okay. This won't be divided by 0. But I want to see the wins over losses. I mean, it doesn't really matter. Win rate also tells us what we want to know. I'm gonna do something, a hack. So this is a hack. Don't do this. But I'm just adding a tiny constant to this so that it's not zero. It's not zero, and it will slightly change the value when we get a non-zero. But it'll be fine. Oh, there's no runtime apps. I thought there was. What is the name of that then? Is it? What is? Okay. Correct way to do this is npf info. No, I don't want that. I just want. No, I don't. Oh wow, that is so ugly. I really thought there was a. How do you get this? Sys float info epsilon. That's pretty ugly too. Eps. Okay, well, we can do it. Okay, since I'm doing something ugly anyway, I'll just hard code something. Let's do 1e minus 16. So it's a tiny number. And yeah, see, it's like making these floating points a little uglier. Well, actually, no, it's not affecting things. You know what? I want to make this. Let's make these like we have up there, 0.2f. All right, there we go. All right, so our win rate's like a below 10%. Win-loss ratio is just jumped to the teens. So let's see how that changes over time. I kind of also want to be impatient and raise the learning rate now because I think things are going in the right direction finally. So let's just raise it. It could be dangerous. It could just blow up and fail. All right, no wins. 1 win. Did I go too far? I am curious. Like, so here's one question we might be able to answer with this current form. If this starts working, then we'll know whether the kind of standard material values are actually the best for this particular style of play. And so the style of play is a little bit non-normal. It's not human. Right? It's randomly scoring every possible move. Sorry, not randomly. It's scoring every single possible move by exponentiating the material advantage, and then randomly sampling based on those probabilities. And that's not how humans play for sure. And that would mean that, like, it's possible. Okay, this doesn't look great right now. The pawns are worth way too much. But that doesn't necessarily mean it's not working. Let's give it some more time. I mean, let's just scroll back, see like the win-loss ratio. It slowly crept up, right? So it began at 0.16. I mean, early on it's like there's a lot of fluctuation, right? So because there's a small number of wins and losses, but yeah, once we had a good number of games, our win-loss ratio was like, yeah, it like was in the teens, and then the 20s, and then the 30s, and then the 40s, and then the 50s. That's weird. So yeah, is this going to answer my question that the material value that we assign, that we typically learn, is like completely wrong, and that we should like overvalue pawns? I think it might be true given the style of play. Like, given the style of play and given that the opponent is playing in this style, maybe pawns are worth more than even queens, because having a queen is not that great if all you can do is like randomly move it. right? You don't get to strategically move it. You only get to randomly move it in a way that doesn't lose the queen. So it's like a different game. This is almost like a dice-based chess, or like you try to gain material, but then once you have the material, you just sort of randomly move the pieces move randomly on their own. You have no control over the pieces essentially, and so it's possible that this is actually. I mean, this looks legit, right? Like this number is consistently going up. What about win rate? Is win rate ever going up? I feel like that might get messed up because there's so many draws. So win rate, okay, it was 0 initially, but that doesn't count. Once it started to stabilize, I mean, it basically is stuck around in the low teens, and it's not going up. So I don't know. I don't know if that's actually an actual signal. Oh, I see. But the other thing to consider is I was confused. The win-loss ratio needs to go above 1. When it goes above 1, then we know we've outperformed the standard weights that black is using. Right? Black is using the 1, 3, 3, 5, 9 scoring. So if we ever get that win-loss ratio, if that ever goes above 1, then we'll know we'll have found something better. So it's possible, right? Yeah, I was confused. At first I was thinking that our player is doing better than the black agent, the black engine, but it's not. It's still doing worse. It's winning at about just a little bit half the time that it loses. So actually, now I'm curious. The pawn value seems to be going down. So maybe it's going to correct maybe it's correcting where it got. No, it's just fluctuating, right? So it was at 8. It was at 5, 8, 7, 8, 9. It went up all the way to 11. I thought I saw it like around 14. Yeah, so it was like 13, 14. And then it goes back. Oh, now we're still stuck at a 14. So, but win-loss rate's still going up. But still, it's worse than black. Yeah, it's still going up. So there's a couple things that are happening here, right? My bad reinforcement learning algorithm, which I just like, I just like threw away like decades of research on reinforcement learning and went and just pretended it's a classification task, which it is clearly not. That might be causing us to be really slow to learn this. It just takes too long for it to learn this, but it is making progress. So at least it's moving things in the right direction. It seems. Although I don't know. I mean, this number, like, it's saying that pawns are worth 20. Again, it could be true. It could be true, but we don't know because we have 0.8 now. And this is okay. The other thing we're not sure about, this is not like a running, or this is a total average over the entire run of this program. So it could be that more recently it's winning more, but I mean, I don't think so. I think if we start seeing a more recent win, we're gonna get closer. The win rate's now 0.15, so that's a little better than it was before. It was around it was in the lower teens before. Now it's in the mid-teens. 0.82. All right, you know what? While this is running, I'm going to set this up so that I can save, so that I can save the weights and load them. It's a little bad form to modify a program while it's running, but I think I can get away with it. So I'm going to say weight file equals file name. Oh no, I don't want that. None. Okay. So let's see. we're going to say if weights is none, let's do, whoops, I'm going to say if weight file load weights from file, and then I'm just going to quickly look up what's the best way to store. I want to store in a NumPy array. It's just like right now it's a small number of weights, so it's, let's see, how to save NumPy to JSON. Okay, let's see. All right. That's kind of ugly. I don't like doing that. I prefer JSON just because it's a portable format, but I could just output a text file at this point. I mean, it's just a list of numbers. ToList and then JSON. Yeah, that seems fine. So I'm going to do JSON loads object. Okay, that looks right. So I just want to do this. Is this really the best way to load something from? Yeah, I guess UTF-8. Okay, this seems fine. So I'll just use that code. So let's import these things. I think codex comes from, is it just its own thing? Yeah. And file path, it will be weight file. And we set it to read. We set the encoding to UTF-8. And we read, and then we need to import JSON. And object text. What was that thing? Object. Oh, it's this. So I'm just going to say, I don't like the name of it. I want to name it something more. Weight text. Let's call it that. All right, and I don't want that. Yeah, I'm also taking this variable naming from it, which I don't like. So we want to just call it. Why do they call it bnew? I don't know. I shouldn't complain. The responder run with Stack Overflow gave a nice answer. So all right, so I'm going to just make the variables name something more meaningful to us. So weight text, we're going to set that to be weight list, and then we just say weight list, and then we just say self.weights. Okay, so what we're doing is we're loading a JSON file, and now we want to be able to save it, and I'll just create a function. Let's just create a function here. Save weights file, file path. And I think it's just a simple, what are they doing? So they just JSON.dump is just this, JSON.dump. Oh, okay. They put a bunch of stuff here. I'm not sure that I need all that. Let me see what they added here. So they said like, okay, so this I think is the object being printed. So let's say weights list equals self dot weights to list. Is that the command? To list. Weight list, and it's writing. We're gonna go in write mode. We're gonna use UTF-8, and they hard coded the separators and the sort keys. I kind of want to just remove all that. I don't know, is that really necessary? I feel like the defaults are going to be good. Let's get rid of that note, and I don't want to call it B. Oh, yeah, weight list. Okay, well that looks correct. All right, whoa, okay, hold on. Okay, let's check the scores. So now we're winning more than we're losing. The win rate's still pretty small. There's a lot of draws. That's to be expected. We're winning more than we lose. Our weights are really weird. It really likes rooks. It really likes pawns. I guess another way to think about this is it's not that it likes rooks, it likes pawn imbalances, right? It likes pawn imbalances, it likes rook imbalances. I mean, it likes all types of imbalances in our favor, right? Every number is positive, but it prefers pawn imbalances to to rooks, then prefers rooks to bishops. Weird. I don't know. I feel like that's. I don't know that we can take too much from this. I'd be interested in watching one of these games. This is which is why I want to save this. But I think because I didn't set up a way to save it now, we can just like copy one of these numbers and put them in as a default as a setting. Actually, let's do that. All right, so I'm gonna let this run for a little bit, and then I'm gonna save. While I let it run, I'm gonna set write a test for the saving and loading, and then I'm going to play a game against this bot, even though it's going to be terrible. So we're going to do test wait saving. I'm going to say engine equals, let's say learning engine waits equals, let's do like, actually, I don't know. So print initialized engine with waits okay, and then we're gonna save it to disk. Dot save waits, and let's call it just temporary temp dot waits. No, let's just, I don't know, we'll just call it waits. I want to save it in a temporary file, but I'll do that later. To do make this a proper temp file. You should always, whenever you do something like this, you should save it in like the temp location in the operating system, so that you're not cluttering your workspace. But for now, I'm just going to do this. Oh, it's a JSON file. Okay, and then I'm going to engine equals learning engine run error, and we're just going to do new engine. Oh shoot, I want it to be wait file equals waits.json. Oh, this is so ugly. I do not like hard coding stuff like this. Let me call it, let's just call it path. Okay, and we're just gonna say path equals waits.json. Okay, that'll make it easier. I just have to do one line here. This will, you know what? I'll just put the comment right on the line where it's gonna happen. So later on, I'll make this a proper temporary file, so it won't clutter the folder we're working in. And yeah, so now I want to do an assertion. So self.assert equals, I don't know what almost equal. See, I don't. Yeah, these are things inside like a Python unit test class, and I don't know if I can do equality of an array. So I think I have to do assert true. All right, so we want new engine.waits and engine.waits. All right, so let's try it. Oh no, it's fine. It's fine. Yeah, I can run multiple things at once in PyCharm. All right, so it failed. So let's see what it said. So initialize. Oh, you know what? I should print new engine. Print new engine loaded with waits. And then print new engine dot waits. It didn't even make it past that point. Oh, toList does not exist. Okay, so what is the correct command there? We have toList. Oh, toList no underscore. Okay, simple. Let's check the score while we're at it. All right, we're winning 1.35% of the time. Let's see. Okay, so this time it crashed. Expected string bytes or OS path like object not list. Which line did this happen? Wait list. Oh shoot. I have to This is file path. That was my mistake. All right, it passed. And it gave a bunch of warnings. That's not good. There's a object allocation problem. Unclosed file. Oh shoot. Okay. This hack. I don't like this. Okay, so let's say does that work? I don't know if this is the correct way to do it. Okay. No. Oh, still a problem. I think when I'm loading it, I have the same problem. Loading, it should be with shoot. Let's do dot read. Not sure what the dot read does. I sort of doubt that you need that. I might be wrong. And now I don't think I need. Oh, I get it. Okay, so I do need that. So we're gonna do we do need this. Okay, no warnings. Weights look identical up to this precision. I wonder what the JSON file looks like. Weights.json. Yeah, so it's that many digits, so that's pretty precise, and we're never going to need that level of precision. But okay, so it's working. So now let's look at the current score. So yeah, we're not gonna. I'm gonna just copy this guy here. We're gonna blow this this bot out of the water, right? I hope. But we can just test to see how it plays. So I'm gonna hard code it to be I guess I want to set it to be. Let me think. The easiest way to do this is for me to just hard code it into the Lichess bot. Is it here? No, that's not where it is. Where do I change? It's not that. Engine wrapper maybe? Yeah, homemade engine. So I want to do from learning engine import learning engine, and then I'm going to return. Oh, we return the class. Oh, that's annoying. All right, then temporarily I'm going to hard code it into learning engine itself. Did I just copy something? I might have threw away my clipboard. All right, so I need to copy this, and I need to hard code it to be so if it's not. All right, so if weights is none, it's going to initialize. So I'm just going to remove this. This is just for curiosity. All right. Let's see. So weights. So self dot weights equals np dot array 25. I'm just going to round it. 13.9, 16.2, 24.96, 9.19. Oh shoot, I forgot to round. 0 and 25. All right, let's run the Lichess spot, and oops, is it working? All right, I'm gonna play against it, so I'm gonna log into my account, my personal account. Challenge to a game, and let's so we can examine it. I'll do real time. It doesn't matter. It's going to play instantly. Okay, so it's going to move around randomly. Weird that I moved the knight twice. That's a weird coincidence, I think. Although it could be a bug. 3 times. Okay, that seems like something's wrong. And then it just. I should have taken the other way. I wonder why. That was really weird. Well, now it's 2 different pawns. But why would it move that knight like that? I'm just going to develop. Okay, so it hung a piece. It doesn't know how to look ahead. Right, so there's no look ahead. And it doesn't understand that a piece is under attack or anything like that. I don't want to trade queens. I mean, this is... Okay, let's see. Okay, random king move. I mean, that was making random moves, which I guess is better than... I don't know why it moved the knight 3 times. Okay, a second king move. So now, again, there could be some weird thing happening with like that. I mean, again, you know, we saw this before. I saw this before. I don't know if other people watched the earlier videos from this series. Before I'd had look ahead, when it was just using material count, it would do this. It would take a piece because, you know, it gets to increase its material advantage, but then it didn't realize that there's there's consequences to the moves that you make. Okay, whatever. Oh no, that sacrifice didn't work at all. I forgot this pawn was defended. Okay, here. Let's use that pin. Did I miss a mate? I feel like there should be a mate here. Is this mate? No. I'm so slow. Oops. Okay. Yeah, I'm not paying attention. Okay, so oh, that was nice. It actually, well, I mean, I guess it's good that it took a hanging piece. Right? So that's a sign that things aren't totally broken. I still don't fully understand what happened with that initial the opening moves. Do I actually have to try? Okay, so let's see if it does weird stuff in the opening again. I think like random moves is not weird to me in this situation. I expect random moves, but sort of like repeat moves by the same piece. That seems like something is wrong, and that could have just been a weird coincidence. Okay, fine, I'll do that. Okay. No, okay. At first I was going to say it's a little weird to have a randomized bot play theory, but it did not. Okay. Yeah. Okay. It's hard to say. It's hard to call. Pawn moves random. Like they sort of look natural. So. Yeah. I mean, created a pawn chain, but that it doesn't know anything about pawn chain, so it can't. Here it doesn't know anything about that either. It doesn't know about being able to take pieces, which is fine. That's to be expected. Okay, it's making random moves. Okay, it's not doing what I think that was just a weird coincidence that it moved. Whoops. You could that was sort of a mouse slip, but not exactly. I just wasn't paying attention. Okay, so I think it's playing the way we expect it to, right? Knowing only material. Right now, it likes pawns more than anything else, as we saw. So is it still running? Did I stop it? Yeah, I did. I had stopped it. I mean, the bot is still running, but the learning process wasn't running anymore. So I'm gonna have it output the learned model and let it run for a while, and then I'm just gonna sign off. So to do that, I'm gonna let's see. So let's say, I mean, why not have it print every? This doesn't take that much resources. Every time we print something, I'll just have it save the file or save the weights. So I'll say white engine, is that what it's called? Engine white dot save weights, and let's just call it weights.txt, weights.json. So it will save the weights so I can load them later as needed. And we'll just run this. I'm going to commit the code. Let's do it in the GUI. Normally I do this in command line, but okay. Engine wrapper, test engine. Fixed some bugs in fake RL engine and added weight saving, loading ability. There's 2 to-dos. Okay. No, I'm going to fix those later. Okay. And let's just run this. Let it go. Did you see that? The win-loss ratio initially was, a bazillion because of that trick, that hack I used. I guess it was 1/0. Okay, so the same process will happen again. It'll be interesting to see if we get different results. I mean, I don't want to run this that long because this is not a real proper. It's not an actual learning algorithm. I mean, it is, but it's not. There's a lot of problems with it. It's not theoretically sound. It's not even correctly a classification loss. It's just sort of like nudging things in the right direction. So it's a start. So I guess the next step, I don't know. One direction I could go is I could increase the feature description. Right. So rather than just using material count, we can look at things like. I mean, we can look at the actual squares the pieces are on. But none of that really becomes. I mean, eventually we can do something more complicated by putting a neural network in as the weights instead of just a linear set of weights. But to do that, you essentially want the input to be at least everything in a fen, right? In a fen encoding. right? So that would mean like the piece positions, the castling rights, en passant squares, um, number of moves since captures, like those types of things, that would sort of signal potential draw. I don't know how to, handling the threefold repetition is going to be really hard. I don't know how to handle that, because it's like not like that's like it's not like a memoryless. It's a memory needing operation. Like you need memory to do that, and that's hard. I don't really want to have to deal with that. It's really annoying. I could just say that our bot will always fall for threefold repetition, and then maybe have the moves be slightly randomized. That'll help minimize that. But just say like it's not gonna avoid that. That's one thing I can do. Yeah. So similar stuff to before, right? It really likes the pawns. I think that's probably an artifact of the game that I've set up where you're just randomly moving. So having more pawns, I guess, is just better. I don't know. Or it might have something to do with the fact that all the opening positions are part of the training, and so it's constantly learning that having an opening at all is good for winning, but it's also good for losing. So you would think it would be less, it would cancel out. And I think we saw last time that initially it did like rooks the most of the actual pieces of the non-pawns. But maybe that's just a coincidence. I'm not sure if I remember exactly how it evolves last time. And I can just quickly look at. I mean, okay, this is potentially not the best idea, but I'm going to open this file, which is constantly being rewritten. But it looks like it's the version that was written to disk when I opened it. So that's cool. That's working. Yeah, I think one thing I can do is just like increase the feature representation, but it has to be enough to capture. I mean, you have to think about like if we keep it in this form where all we're learning is the last, like the weights for all the features, then we need kind of like not just position of the pieces, but like their relative position, right? The relative position tells you whether a piece is under attack by another piece, and you have to think about. What modern engines do now is they just say, okay, let's build a neural network and not worry about what it represents. Like you just let it figure it out. It can learn it to represent anything, any concept on the board. Because you build a giant neural network and let it just learn some nonlinear function from the input to the output. So the input could even be like a fen as a string, right? You could have a sequential model that reads the string characters or something. But it's probably I think it's like bit boards. But yeah, so you probably would pass in the board representation as a tensor. I would guess a natural way to do this is to have what are there 5 different types of pieces? There's pawns, knights, bishops, rooks, queens, and kings. So there's like six dimensions, and you have those and high DBA mechanics. But so you would probably put in a tensor like that, and that would be the position. I guess you need 12 to represent your pieces and your opponent's pieces, and let's see. Yeah, then you would need some other flags for castling rights and other flags for en passant. It's such a corner case annoyance to have to include that, but it's it's part of the rules of chess. You could also optionally include things. Well, anyway, so you include everything that a human player has access to, but then you have to think about which of the more higher level concepts do you want to include. Do you want to include pins, forks? Do you want to include number of attackers per square, right? Like that kind of stuff that we think about as humans playing the game. Okay, we're almost reaching even scoring. Oh, you know what? That hard coding. I don't like the hard coding. Wait a sec. Did I leave that in? Did it initialize at those numbers? No, it somehow initialized to these numbers, which suggests something weird. Okay, let me see. So here I have it set hard code these, but it didn't do that in our training run because why not? Oh, because we initialized it like this. I initialized it to be all ones. That's why. Okay, good. So actually, before I'm just going to remove this now. Shoot, where is that else? Okay, I think that's correct. Yeah, one annoying thing is I want the I want it to load from the weights automatically. You know what? Here's what I'll do. So by default, it'll load. Yeah, this is annoying. So the annoying thing is that Leech's API, the way it works is that this call here, get homemade engine, returns a class, not an object, but a class. So it creates. So it wants to have access to, you know, the class constructor or the class generator, which means that I can't do something like this, right? If I wanted to say, like, give it the weights file that goes against the defaults, it doesn't allow me to do that. So instead I have to figure out how to pass that configuration value in config engine options. I feel like there might be some way to use engine options, but I think a lot of this is specifically for like external. You know, see here it's just doing this. Engine equals get homemade engine, and then engine commands options standard error. Maybe I need to hide things in the commands. I don't know, or options. Yeah, I think that's what I need to do. I need to put it into options. So I have to deal with yeah. So the correct way to do this, I'm gonna undo what I just did. The correct way to do this is to somehow read this stuff correctly, which I have to figure out how that works, and then return the. And then have that include. That's so annoying. I don't want to have to do that. I think maybe I will do it this way and just say that the way you set it to randomly initialize is you set wait file to none. Yep, that's an ugly hack, but it'll work. Oh man. Okay, so I will commit this just so I don't have like a broken version. So removed coded weights, now hard coded weight file or loading from I replaced an ugly thing with a different ugly thing, but I think it's okay. Okay, close that. Let's look at the scores. I mean, not the scores. Oh, knights are worth almost 0 now. That's weird. Okay. Yeah. So rooks and queens. I mean, yeah. Anyway, this version is not winning more than the default values, but it's making progress. Might be kind of stuck though. Okay, probably next time. Hmm. I think I could try to think of a better feature representation. Maybe that's interesting because then I don't have to learn about the fancy, actual reinforcement learning algorithms. I mean, I could just plug it in. I mean, so there's ones I know, like, so I teach Q learning in my classes, but I don't think Q learning is a good fit for this. Maybe it would be fine. Yeah, that's actually better than because like technically, you know what? I think so. One of the things that you have to think about when deciding about your reinforcement learning algorithm is, oh, you know what? Okay, at first I was saying that this I was going to say this is deterministic, but it's not deterministic because we don't know the enemy agent, right? We don't know what the opponent will do, so that's the randomness, right? So we make a move, the opponent makes a move, and we don't know what move they're going to make. So there's a randomness in how the position changes after we make a move. I mean, it's not randomness, but it's a it's a process that we don't know the outcome of. So so maybe Q learning would be a good fit for this. And then it's not that hard. Like Q learning's well, no, but Q learning doesn't work. None of this works that well for because there's so many moves before the win, so we'd have to like we can't actually like learn anything in the middle of a game. So we have to think about how we do Q learning for like long episodes where we only get one signal. I have to do a little reading to figure out what the right tool is for like the easy version of this. I don't want to do the hard version. I want to do the easy version. So I'll have to do some reference to find out exactly what I should be doing. Let me think. So if I do Q learning, so there's something called the temporal difference update in Q learning, which just looks at like here's the results of how much reward we get after we make one move. But that like in this game, the only reward we're going to get is when we make the checkmate, right? So I think we need to when we deliver checkmate, we get a reward. Everything else we don't, and so we'd have to somehow know. Hmm, maybe we need to go to the actor critic setting, and you could think of what I'm doing right now as more of a critic. I don't know. I'll have to look into this. There's different reinforcement learning algorithms. They all have different sort of pros and cons in terms of like ease of implementation. What they work for. Like I thought I was heading toward like a policy gradient based method because I'm kind of learning a policy, but it's not really that because I'm scoring positions, which is like scoring the actual states that we're in. So yeah, some stuff to think about. Okay, all right. This looks like it's just gonna be like this for a while, so I'll just stop now. All right, have a great weekend. Bye.